Dear students, last class, uh, last class we discussed about gas chromatography. Gas chromatography. So in this gas chromatography, what is the basic principle? So through this available gas, it is acting as a carrier that carries the unknown sample into the column. Then it is vaporized by the some thermostat or thermal instruments. We are providing some temperature for the product so that based upon that properties of polar and non-polar of the column and within the sample, some components may reach the first the detector and later it is having other polarities, they may reach second, third like this based upon the I mean for each one which is reached the detector, each one we are representing the some graphical representation. Based upon the graphical representation, we are knowing that which elements having high concentration, therefore we can separate the chemical compounds in the mixture. That is called gas. But in this other, we have other chromatography that is called liquid chromatography. In this liquid chromatography, there will be two phases, as you know that one is mobile phase and one more is stationary phase. Here, mobile phase is nothing but liquid, nothing but liquid, and station phase nothing but the column, nothing but the column. So in this, what it is also called high pressure, high pressure liquid chromatography, high pressure liquid chromatography. So in this, what are the components available? What are the components available in this? Generally, mobile phase nothing but a reservoir, water reservoir. Say for example, water reservoir. It is acting as a mobile phase and pump. We have to pump this call this unknown sample so it is available pump, or you can pump the water into the column along with the sample with the help of pump. And free column, that column you have to provide it. And injector, sample injector means supporting element, supporting device, and column. One more, uh, one more. This is the main column. We have to then temperature controller, thermostat, right, and detector. So this is a diagram for this HPCL, right? High pressure liquid chromatography. Here, uh, this is the this is the solvent A and B, solvent A and B. It's nothing but a reservoir or any liquid reservoir. So, and you need some pumps. So this liquid to be pumped into the column along with sample, along with sample. So we need to take this uh, liquid, liquid. If required, you can place two liquids here for mixing. Otherwise, you take separate mixture along with the pump. You take otherwise other solvent through some pump. You can inject into the column along with the sample. This is sample injection. So in this column, based upon this, the column acting as a stationary phase. So when this liquid acting as a mobile phase and this sample mobile phase and it is also acting as a carrier. This mobile phase carries the unknown sample into the column. So there, this is based upon the polarity, polar or non-polar. After 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 this, based upon the polarities, the chemical components, the elements, they may reach first the detector, first the detector, first, second, third like this. So that may reach the detector that is shown in the graph, in the data system as a graph. See the high peak. High peak refers to the element which is first reach the detector from the column. Second peak refers to second one refers to the second element reach the detector. Third graph refers to The third element within the mixture, that is the detector. So that is the representation of the graph. Based upon this C, this high peak refers to high concentration, second concentration, third concentration, like this. So this area also refers to the concentration. So like this, based upon this graph, we can say that the separate the we can separate this mixture of the unknown sample, thereby we can determine the concentration of the components which are available in the chemical compound, chemical compound. Right? So this is a simple understanding of liquid chromatography or HPCS. Right? So very simple. In the gas chromatography, gas is mobile, and that is acting as carrier. That liquid chromatography, liquid is liquid is the mobile phase. It is acting as a carrier, right? So it carries the unknown sample into the column. Column acting as a stationary phase, right? And in this column, see, this is the simple column which is available like this. Shape of the column. See, consider the heart of the chromatograph is a column station. So, in any maybe gas or maybe liquid chromatography, the heart is the column. So, the complete process is going on in the column. So, this this column phase, stationary phase, separates the sample component C. Separate the sample components of interest using various physical and chemical parameters. Physical and chemical parameters. So, the small particles inside the column are called the called inside the column uh, inside the column we cause high back pressure at normal flow rate. Understand? Small particles inside a column causes high back pressure at normal flow rate. And sometimes the pump must push hard to move the mobile phase through the column, and this resistance causes a high pressure within the chromatograph. So generally, the unknown sample cannot be injected into the column. So we need some pressure. We need some pressure. So we need some supporting pressure system. So that is so called the name relates high pressure. High pressure. So this high pressure, the sample to be injected into the column. That is the meaning of it. And see, there are this is a simple structure of the column. This is a column. This is entrance and is a this is a guard column. This is a porous titanate clips available, and this is ionized aluminum jackets, and is a main column plastic. The main column plastic and porous titanate clips, and this is the exit. So it is entrance and this is the exit. So through the entrance, unknown sample along with the gas or along with the liquid. Suppose it is gas chromatography, along with the gas and unknown sample are entered into the sample. If it is liquid chromatography, the liquid along with the unknown sample are entered into the column. And here exited and placed and detected by the detector followed by a recorder. That is, and see that there are various columns that can be used in the HPCL. So for this high pressure liquid column, we have to use different columns you can use. So maybe God column. So this is nothing but a God column. The shape is like this, God shape, God column. Derivative is in column, derivative is in column, and sometimes capillary column, fast column, analytical column, preparatory column. So as per your requirement, the sample to be analyzed, the sample to be summarized. So which column is suitable for this? So select accordingly the available column. Next, what are the recorders and integrators we can use in the cryptography? Recorders are what recorders are used to record responses obtained from the detectors after amplification if necessary. So, if you want to uh, first record the output of the column, after record you have to amplify it, right? If it requires. And the record, the baseline and all peaks obtained with respect to time. With respect to time. Isn't it? So the output of recorder we have to represent as a vertical line or a high peak line separately. For each component, we have to represent a peak line. Suppose in the picture we have four components. We have to represent the output of detector into four peaks. Each peak refers to for separate component. Each peak refers its concentration. Its concentration. So if a graph having four peaks, four separate peaks refers to four components are available and its concentration in the of the unknown sample, right? And one more, retention time can be found out from these recordings, but area under curve cannot be determined. Sometimes there is a drawback in this. Uh, you cannot directly uh, get that area of the recorded graph. You have to calculate this separately. Okay? Sometimes you see the selection of detectors and selection of detector. So based upon this type, detector type and type of components can be detected. So what type of components can be detected? Suppose if it is a UV visible detector, compounds with chromophores such as aromatic rings or multiple alternating double bonds can be detected. If it is RF fluorescent components usually with fused rings or highly conjugated planar systems can be detected. And in this CBD, charged compounds such as inorganic ions and organic acids can be detected. If we use PCB for easily oxidized components like uh, quinones or amines can be detected. RID and EFSP compounds that do not show characteristics usable by other detectors, example polymers and saturates, right? These can be detected. So these are instrumentation for already this can be discussed in the last class. So UV ultraviolet visible detector, ultraviolet visible detector. So we are using this type of photo detector content. And in this one more, we can have refractive index detector. Refractive index detector. Um, we can also have um, refractive index detector. See, we will see later this one, right? And fluorescent detector and photo array detector and NMR. We will see this NMR in the next class, right? If you have any doubts regarding this chromatography, gas and liquid, you can ask me, right? I will clear all your doubts.